To Algebra with Miss Swartz. Today we are going to continue with our inequalities unit. We're really getting into some more meaty stuff. I know the first couple days of this chapter have been fairly easy, but luckily this first part of the chapter in general is a lot of review. So we're solving one-step inequalities. We're going to break it down into a few different pieces here. There's going to be a lot of core concepts that you don't necessarily have to write down. They will be in your journal. I'll try to point out those pages as they come up. We are covering two sections here, section 2.2 and 2.3. We're combining those into one, so just be ready for that. We're going to look at addition, subtraction, multiplication, and division here. So we'll kind of step through, do some examples of each one. So the first core concept on page 35 in your journal is the addition property of inequality. So adding the same number to each side of an inequality produces an equivalent inequality, very similar to the addition property of equality that we talked about with equations. Okay, so again, don't necessarily have to write this down, it's in your journal, but if -3 is less than 2, if I add 4 to both sides, it's still going to be true because I've kept it equal, I've kept it balanced in this case, so 1 is less than 6. Same thing here, if I add 3 to both sides, okay, it's not going to change what happens with my inequality as long as I do it to both sides. So some examples of solving some addition problems. They're one step, very similar to solving equations, which makes this a lot of review, but our goal is to get x by itself so we know the solution set of the inequality. So to get x by itself, I'm going to add 6 to both sides using the inverse operation. So I would have x is greater than or equal to -4. Once I'm at this point, now I can easily graph the solution. Okay, so x is in front. I have a closed circle at 4, shaded to the right. As I said, you've probably done this before, so nothing new. So let's try number 1 here. Add 2 to both sides. B is then less than -7, and I could graph it easily here. B is in front, I have an open circle shaded to the right. So one way that we could do this, we could check the inequality, a little different than how we check equations, but I can pick any number that's greater than -7, so I can pick 0. -2 should be greater than -9, so -2 is greater than -9, that's true. I know I got it right. So any number greater than -7 I can choose to plug in to check to see if I solve that inequality correctly. So go ahead and try number 2 on your own and pause it if you need. So moving on here, now we have the subtraction property of inequality, not much different than the addition property of inequality. So subtracting the same number from each side of the inequality produces an equivalent inequality. This is on page 36 in your journal. So if I have -3 is less than or equal to 1, I subtract 5 from both sides, I have -8 is less than or equal to -4. Very similar again to the subtraction property of equality with equations. Okay, so let's do some examples of this. If I am solving this inequality, I'm trying to get y by itself, so I'm going to use the inverse operation of subtraction. Subtract 8 from both sides, so y is going to be less than or equal to -3. Graph it. Closed circle at -3. Y is on the front, so I can look at my arrow shaded to the left. So I could check this. I could pick any number that is less than -3. So let's say -5 plus 8 should be less than or equal to 5. This would be 3 is less than or equal to 5. That's good. Go ahead and try letter B. But make sure that you're aware that the m is on the right side of this inequality. So you might have to switch that around to make sure you graph it correctly. Okay, so that's section 2.2. Pretty simple. Okay. Since we've worked with equations, it's basically the same concepts with inequalities. So let's jump over to multiplication and division. They have the same exact properties. We have to talk about a couple things here. So now we're on page 40 of your journal. So the multiplication property of inequalities says, okay, notice here, this is the one where C is greater than 0. Multiplying or dividing each side of an inequality by the same positive number produces an equivalent inequality. So, nothing new or crazy here. Negative 6 is less than 8. If we multiply by 2 on both sides, still going to be true as long as we do the same to both sides. Okay. The difference comes in when C is negative. Okay, so if C is less than 0, multiplying or dividing each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed to produce an equivalent inequality. So this is our big change here. Okay, notice negative 6 is less than 8. If I multiplied both by negative 2, it would no longer be true if I kept the sign as less than. Okay, so anytime we multiply or divide by a negative number, we must switch the sign. Inequality sign. Okay, so that's the biggest piece to remember. So let's look at a couple examples of that. Okay, we have x divided by negative 3 is less than or equal to negative 9. So if I'm going to solve this, okay, I want to get x alone. X is being divided by negative 3, so I'm going to multiply by a negative 3 on both sides. Since I'm multiplying by a negative number, okay, I need to flip my inequality symbol. So instead of less than, I'm going to have greater than, maybe, or equal to. And negative 9 times negative 3 is positive 27. And that is mainly the reason why we flip it, because the negative impacts, if we multiply a negative times a negative, it's going to be positive. So that's really going to impact if our inequality is true. So now, if I graph it, this would be a small graph. Okay, closed circle at 27, shaded to the right. So I could try any number that's greater than 27 in this inequality. So I'm going to choose a number that's divisible by 3. I'm going to choose 30, which is something easy. Should be less than negative 9, or should be greater than negative 9, excuse me. So negative 10. Whoops. I love when I make mistakes on videos. Okay, let's try this again. If we're plugging it back into the original piece, okay, if I use 30, I have to keep my inequality where it's at, okay, even though this is what it's telling me here, okay, so I'm going to compare negative 10 should be less than negative 9. Is that true? Yes, it is. So we know 30 is correct, so we know that we have it graphed correctly. Okay, next one, we're going to divide by 4. Now, did we multiply or divide by a negative number? We did not. We have a negative number here, but we did not multiply or divide by a negative number. So our sign does not change. So negative 2 is greater than x. So I'm going to switch that around. X then is less than negative 2, and I can graph that. I have an open circle at negative 2, shaded to the left. You could pick any number, negative 3 here, so negative 8 should be less than, or sorry, greater than negative 12. that is true. Okay. Awesome. So we've hit on all of our core concepts. Okay. Nothing's really new except for when we have those negative numbers that we're either multiplying or dividing by. We do have to write sentences as inequalities and solve. So I did want to review that. We did it a little bit yesterday. So I put a couple of those in here. It says a number minus 3 is at least negative 5. So a number, we're going to call that x, minus 3 is at least, okay? So if it's at least, the question you should ask yourself is, could it be bigger or could it be smaller? So if it's at least, could it be bigger? Well, yes, because it's at least. So we're going to say greater than or equal to negative 5. Then to solve this, I'm going to add 3 to both sides. So x is going to be greater than or equal to negative 2. Try this one down here. And we'll look at one more problem here. It's a story problem. You'll have a couple of those on your homework, so I want to make sure that we hit on that a little bit. Okay, these story problems are going to have you write an inequality and then solve. Sorry for the loud cars. You have $30 to spend on groceries. You have $15.75 worth of groceries in your cart already. It says write an inequality that represents how much more money M you can spend on groceries and then solve the inequality. Okay, so we can't spend more than 30. Okay, so that's kind of our starting point. So 30 is the most we have. Okay, so the cost of our groceries has to be less than or equal to 30. That kind of gets us the ball rolling. I already have $15.75 in my cart. I could add to that however much more money I want to spend, so that's going to be M. Okay, so here's my inequality that I wrote, and then to solve it, okay, I'm going to have you go ahead and try to solve that. Okay, just get M alone and work that way. The biggest part there is being able to set up that inequality. So we knew that we only had 30 to spend, so whatever we spend over here has to be less than or equal to 30. Awesome, so we are done for today with the video. Your homework is a little bit longer one, but you have until Friday to get it done. So your homework is in your journal on pages 31 and 32. Okay, so that's numbers 1 through 14. And also pages 36 through 37, numbers 1 through 7. So it's really not that bad, and a lot of them are pretty simple, but I just want you to get practice in all of the different types of problems we worked on today. Have a great day. We will see you next time.